Hello. This tutorial is designed to take you through the process of using machine learning classification algorithms to classify data. This includes visualizing the data as well as constructing different classifiers and setting up a pipeline that you can use to compare different classifiers. In this video, we will look at the data visualization aspect. So there is a Jupyter notebook that includes all of the steps that you will need to do. And there are various places in the notebook where you will have to include code, and these places are clearly marked. So this tutorial will show you how to visualize biochemical assay data from Rooibos tea samples using Python. So we are using some biochemical data from Rooibos tea. Now this is not important for the mathematics or the programming. This is just telling you where the data comes from. We will actually be looking at Rooibos tea data of two types, fermented and non-fermented. And our goal will be to classify fermented and non-fermented based on the biochemical properties. So we will use the biochemical properties to determine fermented or non-fermented. So in this tutorial, you will learn how to read data into Python from an Excel file. This is important because your data is often in a spreadsheet. How to use data frames, which is the pandas package in Python. How to visualize and compare biochemical properties of fermented and unfermented Rooibos tea using histograms. So the biochemical properties will have a certain distribution, and histograms can tell you what the distribution is. I'll explain more about that when we get there. And how to use commands using example codes from the internet. Okay. So the internet is always a very good resource for coding. Usually you can find an example on the internet of the type of code that you want to do. So let's get started. If we want to use Python, we need to import the Python packages that are used and have the functions required to process our data. So note, you will need to run all the cells in the notebook in order for it to work properly. The best way to do this is run them one by one. You can also use cell, run all above, or cell, run all below. But if you change an earlier cell, you will need to rerun all the cells following that cell in order to make the change affect your current cell. Okay? So just understand that the cells are executed in order. So if you change a previous cell, you need to re-execute the cells following the cell that you changed. Now here are some libraries that we will use. These have different Python functions. Pandas imports data and manipulates data frames. A data frame is what you call a data structure that contains the data in a structured format. Seaborn is useful for drawing graphs, such as bar graphs, and PyPlot also is another graphics library. Now, when you import packages, you use aliases. So when I refer to a function from pandas, I'll not use the word pandas, I'll use PD. So I can tell you the first command would be import pandas as PD. So the first command would be import pandas as PD. And the other commands will be similar. So you will have 3 import statements in this cell. Then we have to read in the data. Now you should have this function or rig.xlsx in the data folder. So if this notebook is in a file, the data folder should be in the same location as this notebook. Right? So, so make sure that you have a data folder and your file orig.xlsx is in the data folder. Okay. So you'll use read Excel to read in the fermented and non-fermented data. Now, the command read Excel has several options, which you can find on the internet. The actual file that we have, orig.xlsx, is organized in a certain way. And here, let me pull up the file so you can see. You can see that this Excel sheet has this Excel spreadsheet has various sheets. There's the FER sheet, which contains fermented samples. There's the non-FER, which contains non-fermented. Let me make this a little bit bigger so you can see what's going on. So both for fermented and non-fermented, you have the type, and you can see in the fermented sheet, the type is all 1. In the non-fermented sheet, the type is all 0. So the 1 and the 0 are what we want to predict. Apart from this, we have several chemical properties. 1, 2, 3, 4, 5, 6 chemical properties. Cut we will not be using. We have these 6 properties. Notice that the first 2 have H2O and the last 3 have MEOH. Now that refers to the solvent that is used to measure these quantities. And here you have F, A1, A2 for H2O, F, A1, A2 for MEOH. So we're measuring the same quantities with 2 different solvents. So we don't need to get very deep into the biochemistry, just to help you understand the organization of the data. Let's go back to our Jupyter Notebook. So we will be using read Excel to read the fermented and non-fermented data. As you saw, the fermented data is in the sheet FER, down here, FER, if you can read that. And the non-fermented data is in the sheet non-FER. So you will have to arrange this command, read Excel, to get the data. Now here are some examples of how you use the read Excel command. So if I had a spreadsheet called temp.xlsx and I wanted to read from a sheet named sheet 3, then I would use temp.xlsx as the first argument of read Excel and the sheet name sheet 3 as the second. Now, if your data has an index column, you would specify the index column here. In fact, our data does not have an index column. It simply has the type in the first column, which is not an index. So we would not use the index column. Now here's another example of syntax. This would be the name of the file. Here there's no sheet name specified. Presumably there's only one sheet. There's no index column. And then here's a header. Header equals none means there's no row that identifies the data. Now in our case, we do have a header because we have names of the different columns. So our header is in row 0. Right? So you can use that information and these examples to read in the data. So make sure when you read in the data that you get, well, that's the next exercise. In the next exercise, you will read in the data and make sure when you read in the data that you obtain these, well, you should obtain these 8 columns, and also that you start with the first row here. The first row in your data should agree with the first row in the spreadsheet. So make sure that it does agree. So you can display the first 5 rows using head, and this explains how to use the command head. So you can, if this one asks you to display the last five rows, and there are more instructions here about how to display the two parts of the data frame on the same display. So let's move on. All right, so this simply explains the different variables that we have. So as I said, we have 1, 2, 3, 4, 5, 6, 7, 8, and we'll only use 7 of them. So this explains why we're interested. These chemicals are various antioxidants which are important for health. And the H2O and the MEOH are two different methods for measuring these quantities. In fact, the H2O measurement is much easier and less expensive, and the MEOH is more difficult. So you will create two data frames, one for non-fermented and one fermented. Here you're supposed to display the shape of both data sets. That includes the number of rows and the number of columns. The number of rows is the number of samples, and the number of columns is the number of features. In fact, the first column is not a feature, so we really should take the number of columns minus 1. But that's not terribly important. Okay? You can display the number of rows and number of columns in these two data frames. Now, just to see what we're studying, this is what fermented Rooibos looks like. This is what non-fermented Rooibos looks like. So you might ask the question, why do we want to classify fermented and non-fermented when it's obvious just from looking that fermented is different from non-fermented? Well, we want to see the association between these two types and the different biochemical properties. So perhaps fermented Rooibos has more antioxidants than non-fermented. We'll be able to see that through our analysis. Okay. Now, the variable names that we have are given in the data frame. So FMEOH, A1MEOH, and so on. We want to change those names, and the way to do that is to use the rename function. Here's an example of rename. Suppose you have a data frame that's arranged in this way. You see the 0, 1, 2 is the index. These are the column names, so these would be the features. Now you can see that this rename command, arranged in this way, will change the columns. So this first command changed X, A to X, and B to Y. And all three of these commands will give the same output. So you can see how that works. So you should be able to follow that example to change the name. Yeah, so this F is really TPC, this A1 is really TEAC, this A2 is really FRAC. So notice that here we have F and a dash, here we have TPC and an underscore. It's very important to make sure that your names have been changed correctly. So once you change the names, make sure the names are changed correctly. Otherwise, you'll have problems in the remaining parts of the notebook. So you want to display the column names. And here is an example of how you would display column names. There's all of these give different ways of displaying column names. They're all the same. You can use any one of these to display the column names. Make sure when you display the column names that the new column names are correct. Now we want to put non-fermented and fermented into a single data frame. So this gives you an example of how to take two data frames and put them together. So here this has DF3. We've already defined a DF1, and these are put together. So you can follow that syntax. Then you want to display. You already know how to display. And now we use Seaborn to draw a histogram. So this cell you don't need to change. This explains all the options in this cell, so you can read that in case you want to make a histogram. But you don't need to change anything in this cell. Now, one thing you should be able to do is, from the histogram, you should be able to identify the mean, variance, and skew of different distributions. So the mean is the center of the distribution in some sense. The variance measures the width of the distribution. Standard deviation is the square root of the variance. So if the standard deviation is large, the variance is large. So if you have two distributions, you should be able to tell which one has the higher mean and which one has the higher standard deviation or variance. If the variance is similar to both, then you simply can say that you can't tell the difference between the variance. Now, skew is illustrated by this picture. This is called positive skew or right skew. You can see that there's a kind of tail to the right. The histogram goes up steeply and goes down gradually. Now you can see that the mean here is to the right of the maximum, and that's typical for a right skewed distribution. Negative skew or left skew is the other way. The tail is to the left. Now sometimes it's difficult to tell the skew, so you can just say there is no skew. But if there's a pronounced skew, you should be able to identify. So we have these questions here. Which type has the higher mean? Which type has the larger variance? Which type has the more skew? And what is the skew of each distribution, right or left? Again, right would be what he calls positive, left would be negative. Now, which of the distributions is bimodal? So we can show an example of bimodal distribution. So here's an example of a histogram of a bimodal distribution. You can see that there are two humps or two maxima. Each one of these is called a mode. Now sometimes in your data it may look bimodal, but that's just because there's not so much data. That can happen as well. But if you have two pronounced maxima, you can say that the data is bimodal. All right. So you should be able to answer some of these. Now, this gives some example answers. These examples would be referred to the histogram that's created above. Now, for the rest of the Jupyter Notebook, you simply do the other histograms and the analysis for the other variables in the same way. Finally, very important, you need to save the data frames that you created. DFNF, which is the non-fermented, DFFER, which is the fermented, and DF, which is the data frame combined. So in this notebook, you would write something like this: store, and then the name of the variable. So you have three variables, so you'll have to store three variables. Now you can simply store the three variables, separate them by commas, in a single line, or you can have 3 lines where you have 3 store statements. Now later on, when you want to recover the data, you will use this command, store.-r data. So later on, when we go to the second notebook, you will be using this command to recover this data. Okay, so I hope that's useful for you and explains how to use this notebook.